Here you can see the layout for the Chris 360. You can see that we've got 4 lights surrounding the product. There's 2 opposing cameras on the left and the right side, with 1/3 camera over the top looking at the lid. With those 3 cameras, we can do a full 360-degree read of the cup as well as the lid. Here you can see the main operator interface panel with 3 different camera views, the 2 side views and the top view of the lid. On the right hand side down below you'll see an RFID key reader. That's what the operator uses to interface to choose different products and clear any faults that the screen has. And the main Allen Bradley panel there is actually displaying the valid cup from the side and the valid lid on the top. Here you see the product from the camera's point of view. Notice the lens in the foreground and the product will be running by. Notice also that sometimes you can see the barcode and sometimes you can't see the barcode. So on the cup that's directly in front, we would actually be using the graphics to identify the cup. Here you can see a picture of the Cheerios cup with a bunch of blue points on it. Those points are what we call key points. So even though it's taking a 1.5 megapixel camera picture, the only valid pixels are the ones with blue dots on them. The pixels represent areas where there's a significant change in contrast, where there's unique structure around an area. Notice that there's no pixels in a big common area, such as the area above the double E in Cheerios. For the Chris 360, which is fundamentally designed for round touching products where the barcode is not always going to be visible, we're using sometimes barcode and sometimes graphics to analyze the cups. What we've done is taken 36 images of a cup, rotating the cup every 10 degrees. Here we can see as the cup rotates through, sometimes we'll decode the barcode and sometimes we'll use the key points to do the analysis and validate that it is the correct package. This is the graphic that represents the 360-degree product verification. You can see that camera 1 has a barcode reading area, camera 2 has a barcode reading area. If the barcode is visible to the camera in that indicated area, it will identify the cup based on the barcode. If the barcode is not visible and falls in the key point verification area, the system will use key points instead of the barcode to validate that the cup is in fact the correct SKU number. Here's a quick screen split showing both the product running by on the conveyor and the screen as it appears to the operator during run. Next, we're going to demonstrate a no-read situation where both the graphics and the barcode has been covered up for the side cameras. When the product is placed in the run stream, it will be rejected by a perfectly timed air blast that will not affect the leading or the trailing cup and only spit out the cup that's having an issue being read. Next, we're going to add 2 more non-readable products to show that 3 consecutive no reads shuts the line down. Now we're going to insert a mismatch product. The product itself will never be allowed to pass the reject point. It will be rejected as a mismatch product and the line will be shut down and locked out such that a higher level person such as a supervisor has to log in with their RFID key and reset the system, a feature that the operator does not have access to if it's a product mismatch.